Alright people, so welcome to Jumbo IAS and welcome to UPSC Prelims Phoenix batch. In this batch, we revise the entire syllabus for UPSC Prelims examination. Now here's the thing. In this batch, we'll be covering both static as well as current affairs because both topics are important. Now this particular lecture is related to the current affairs lecture series. And now you all know, because you have been following us for quite some time, that currently we are going through science and technology related current affairs. Okay. Now today is day 7 for science and technology related current affairs, and today's targets were, well, miscellaneous current affairs related to science and technology. Okay, so all the leftover current affairs that are still important, okay, we have put it in miscellaneous category. So these current affairs are still extremely important. A lot of developments have happened in the past year and the beginning of this year also, Jan, Feb, March. Okay, so we'll be covering all these current affairs through a set of 20 MCQs. Right? Now, I'm hoping that you have already gone through the notes that we have provided to you. Okay, you have already gone through the notes. Now, you will be going through them again through a set of 20 MCQs while watching this lecture. Okay, so let's begin without further delay. So, science and technology related current affairs, day 7, and well, today we'll be covering miscellaneous current affairs. It includes nuclear energy, other alternative sources of energy, and many other topics. Okay, now let's start with question number 1. So, yeah. Regarding the prototype fast breeder reactor at Kalpakkam, which of the following statements are correct? It utilizes heavy water as moderator to slow down neutrons to achieve criticality. It operates at high pressure to prevent the coolant from boiling at operating temperatures. It represents the transition of India into second stage of its 3-stage nuclear power program. Now, this recent development of prototype fast breeder reactor is a landmark development for India's nuclear power program. Okay, especially civilian nuclear power program. Why so? Because back in the day in 1960s, father of nuclear program in India, Homi J. Bhabha, well realized that India is short of uranium, a very important nuclear fuel. Okay, we are short of uranium. Therefore, we can't be self-reliant when it comes to that. We have to be import dependent for uranium to power our nuclear reactors. But we have a surplus of thorium. Now, thorium can be used as a nuclear fuel. It's not as good as uranium or plutonium, but it can be used. It can be converted into something which can be used as a nuclear fuel. Okay, so for that reason, he devised a 3-stage plan. Okay, in that 3-stage plan, well, number 1, first of all, in the first stage, well, it would be pressurized heavy water reactor. In that, we'll use natural uranium, that is uranium-238. Okay, now it will produce energy, but it will also produce a byproduct called plutonium, which is a fissile material. Once we have developed enough reserves of plutonium, then what we'll do is we'll create a fast breeder reactor. This is second stage. In this, the nuclear fuel will be plutonium-239 plus uranium-238. Now, this is a special thing. Why is it called fast breeder? Why is there the word breeder here? Okay, because plutonium-239 will undergo nuclear fission and produce energy. Along with that, uranium-238, because of this nuclear reaction, uranium-238 will be converted into plutonium as a byproduct. It is such a type of reaction in which energy would be produced and this uranium-238 would be converted. Now, the technical term for this is transmutated. Transmutated into plutonium-239. Okay, so plutonium is the actual fuel, but the reason why is it called breeder is because it will use up the fuel, it will consume fuel, and it will also produce fuel for next stage. Okay, so in a sense, this breeder produces more fuel than it consumes for nuclear energy. This is special. And at the later stage of second stage, we'll also add thorium as a blanket material. Okay, because of this reaction, thorium would get converted into uranium-233. And once we have built up enough reserves of uranium-233, then comes the self-reliant stage, and that is the third stage. And what will be the third stage? Well, the third stage would be, pay close attention, in the third stage, it would be thorium-based reactors. In that, what we'll do is that the fuel would be uranium-233 plus thorium of which we have no shortage. This would produce energy, and this would get transmutated to uranium-233, which will be used over here again. And this cycle would go on. And we have no shortage of thorium. So India will be self-reliant. We are not dependent on any country for uranium. That was the plan. But for so many years, we were still stuck at first stage. But this April of 2026, we have officially entered second stage with the development of prototype fast breeder reactor at Kalpakkam. Okay, it has achieved criticality. And what is criticality? We'll cover that in the subsequent MCQs. But I hope you got the three-stage plan. Now let's take a look at this. Now this this fast breeder reactor, the reason why it's called breeder is because, well, it produces more fuel than it consumes. It breeds more fuel than it consumes. Okay. Now, it utilizes heavy water as a moderator. That is not at all correct because it doesn't require moderator at all. You see, in our first stage, we had pressurized heavy water reactor. That required a moderator and a coolant. Okay. Why moderator? To basically slow down the speed of fast moving neutrons. For that reason, we used a moderator. But in fast breeder reactors, we do not slow down the speed of neutrons at all. Hence, it is called fast. So we don't need a moderator. Okay. We need a coolant, and that coolant is liquid sodium. So first statement is false. It operates at high pressure to prevent the coolant from boiling. Now, generally the problems, if you use water as a coolant, then that water would boil very quickly and convert into steam, not acting as a coolant anymore. That is why you have to apply very high pressure, because high pressure increases the boiling point of water. But in this case, we use liquid sodium. Liquid sodium already has very high boiling point. You do not have to apply high pressure to increase its boiling point. It already has very high boiling point, so you don't have to apply extra pressure also. So no extra pressure is required. It works at atmospheric pressure. It represents the transition of India into second stage. This is absolutely correct. Okay, so the answer would come out to be A. Right? Next. With reference to the breeding mechanism in India's prototype fast breeder reactor, consider the following statements. The reactor produces more fissile material than it consumes. Absolutely correct. We just discussed this. The core uses a combination of plutonium and uranium-238. We just discussed it. Okay, this is the fuel combination in the core of the reactor. Transmutation occurs when fast neutrons convert thorium blanket into uranium-233 during this specific stage. Yes, this is also transmutation, and U-238 into plutonium-239 is also transmutation. So this is also correct. Okay, all statements are correct. Make sense? Next. Yeah, so the reason why Kalpakkam prototype fast breeder reactor was in news was because, well, the news was that it has achieved criticality. Okay, now what is criticality? Look, a nuclear reactor produces nuclear energy because of nuclear chain reaction. So a nuclear chain reaction goes underway, and that's when it produces nuclear energy. But to sustain this nuclear chain reaction, you have to do certain things. Okay, let's put it this way, simply. So you have to sustain this nuclear chain reaction externally so that it goes on and on. Then it goes on and on and on, and then it becomes self-sustaining. It automatically conducts this nuclear chain reaction without any outside interference. The nuclear chain reaction is automatically happening without any external interference. When the nuclear chain reaction becomes self-sustaining, that's when we say that the nuclear reactor has gone critical. Okay? So the state where the number of neutrons produced in a nuclear chain reaction equals the number of neutrons produced in a nuclear chain reaction equals the number of neutrons lost. Hence, the reaction is self-sustaining. Because the reason why the nuclear power plant shuts down is because more neutrons are getting lost than are being produced, new neutrons being produced. And hence, the nuclear reaction cannot go on. But once this happens, well, neutrons are dying down, new neutrons are being produced to replace it, and they are continuing with the reaction. B. Okay, next. Consider the following pairs regarding India's small modular reactor designs. Okay. Now, the thing is that, well, the reason why nuclear power is not that popular is because it is risky also. It is prone to accidents. But nuclear power is useful because it is green energy. Why green? Because it does not emit any greenhouse gases. So it doesn't cause global warming. That's why people are promoting nuclear energy. But nuclear energy is risky also, prone to accidents. So a way out has been uh, thought of. And that is small reactors. Small modular reactors will produce green energy, but they're not that risky. Okay. Now, small modular reactors are those reactors which produce less energy. Okay, around up to 300 megawatts. Now, there are many reactors that have been designed. Okay, you just have to match the following. So this BSMR 200, Bharat Small Modular Reactor. It is a pressurized water reactor technology. Absolutely correct. Small modular reactor 55. It is intended to provide, it is for captive power. What do you mean by captive power? Well, a company can use it for its own industrial establishment or an industrial region, SEZ. So this nuclear reactor won't power every household in the vicinity. It will only power the factories. Captive. Yes. HTGCR. It stands for high temperature gas cooled reactor. Okay. Now, why is it called gas cooled? Because the coolant used in this reactor is helium, which is a gas. So gas cooled reactor. Now this gas cooled reactor is extremely green and it can be used to produce green hydrogen. You see, to produce green hydrogen, you require electricity. Now, if that electricity is coming from burning coal, then it defeats the whole purpose of producing green hydrogen, because then you're using electricity that emits greenhouse gases. But this HTGCR won't emit any greenhouse gases, and green hydrogen would be produced, which will act as a fuel, which when burnt will produce energy and no greenhouse gases. So green hydrogen. So yes, this is also correctly matched. All are correctly matched. Okay, next. Regarding the Strategic High-Level Action for Nuclear Technology Integration, Shanti Act of 2025, which the government enacted through Parliament. Consider the following. It allows private players to invest in and operate nuclear plants under government oversight. It prohibits foreign investment in small modular reactor deployment to maintain strategic autonomy. It establishes an independent nuclear regulator to streamline licensing for modular designs. So for the first time, well, the government has allowed private players, even foreign players, to enter India's nuclear sector through this new law. So first statement is correct. Second is false, because it does not prohibit foreign investment. It encourages foreign investment in this area. And it has advised establishing a new nuclear regulator. Currently, it's Atomic Energy Regulatory Board. We need a new regulator so that it licenses the designs of these reactors. Only safe designs would be permitted. Okay, so yeah, C. Clear? Next. With reference to nuclear fusion, consider the following statements. It releases nearly 4 times more energy per unit mass than nuclear fission. Unlike fission, it is not a chain reaction, which inherently eliminates the risk of runaway reaction, that it goes out of control. The process requires temperatures of approximately 150 million degrees Celsius to overcome electrostatic repulsion. Now look, nuclear energy can come through nuclear reactions. There are 2 types of nuclear reactions. Fission, which is the common, in which we use uranium, plutonium, thorium. We break down a heavy nucleus. And then nuclear fusion. So fission means you break down a heavy nucleus of an atom. Fusion means you combine 2 nucleuses of an atom to produce a bigger nucleus. This produces a lot of energy. Okay. Now the thing is, nuclear fusion reactions are happening in all stars. That's how stars get their energy. Our sun is performing nuclear fusion to produce light and heat energy. Okay. But currently we have mastered nuclear fission only. Okay, to produce electricity. We are going through experiments to master nuclear fusion to produce electricity, but currently we have mastered nuclear fission. But nuclear fusion is advantageous. Why? Well, first of all, it doesn't require any nuclear fuel like uranium, plutonium. It only requires hydrogen, because it combines 2 hydrogen to produce helium, That is the nuclear fusion that is happening, combination. Plus it releases more energy, 4 times more energy. Plus there is no chain reaction, there are no neutrons firing up. Okay, so there is no risk of using moderators to slow down the reaction. But the only problem is, and that is why they are not possible on Earth, is because it requires very high temperatures to perform these reactions, fusion reactions. Okay, now 150 million degrees Celsius temperature is required so that this reaction happens. Now such temperatures are available at Sun, but not on Earth. Hence it is difficult on Earth, though we are experimenting with this. So this is correct. Okay, all. Next. Now, currently many countries are working together to produce a nuclear fusion reactor. It is called ITER, International Thermonuclear Experimental Reactor. India is part of this experiment along with other countries. Now, which of the following components were manufactured provided by India? The world's largest high vacuum pressure chamber, cryosat, in which the fusion reaction would happen? Yes. In-wall shielding blocks to protect the reactor from high energy neutrons? Yes. RF heating systems to heat the plasma? Yes. All are being provided by India. Okay, next. In the context of fusion research in India, what is the significance of SST1? Okay, so it is basically a tokamak that will hold plasma, because nuclear fusion reactions happen in the plasma medium, not solid medium, not liquid medium, not gaseous medium, plasma medium. So you need an instrument to hold this plasma. This is ionized gas. So tokamak, advanced experimental tokamak using superconducting magnets for long duration plasma discharge. This was also built by India. B. Next. Yeah. So currently we are going towards electric vehicles and many other green technologies, but those green technologies require batteries. Now, the most famous battery is lithium-ion battery. Okay, but this extreme reliance on lithium is also counterproductive, because then, well, what about those countries which do not have access to lithium? That is why Indian government wants to diversify, move beyond lithium-ion batteries. Okay, so beyond lithium-ion battery technologies mentioned in 2026 reports, consider the following statements. Sodium-ion batteries are safer than lithium-ion as they pose no risk of thermal runaway, extreme temperatures, heating up. Yes. Solid-state batteries replace the liquid electrolyte within the batteries with a solid ceramic and polymer, offering higher energy density. That means more energy per gram of fuel, electrolyte. Yes. Aluminium air batteries are easily rechargeable by reversing the current. Actually, aluminium air batteries are also being proposed. The only risk is that they are not rechargeable at all. So that is why many people won't use it. So not easily, they're not at all rechargeable. So A. Okay, next. With reference to National Critical Mineral Mission, consider the following statements. It aims to secure the supply chain for 30 identified critical minerals. Geological Survey of India is tasked with over 1,000 exploration projects under this mission. It sets a target to recover 400 kilotons of minerals from electronic and industrial waste. Now, critical minerals are those minerals which are extremely important and significant for India's defense, economy, everything. That's why they are called critical. For example, lithium for lithium-ion batteries, cadmium for many other applications. Now, the thing is, there is one category of critical minerals called rare earth elements. China has a near monopoly over this. Okay, that means that if India wants to build anything which requires these rare earth elements, it would have to import it from China. China has achieved near monopoly. Now, India doesn't want to be dependent on China. That's why we want to secure our own supply of critical minerals. For that, we have to, well, increase our exploration projects in India as well as overseas also. We need to explore more minerals, okay, find them, mining should be done, and then secure them for us. We can't be dependent on China. For that, we launched National Critical Minerals Mission. Now, it aims to secure the supply chain for these critical minerals. Yes, India has identified 30 minerals which are critical for India. Every country has a different list of critical minerals based on its criticality for their country. So these 30 minerals are critical for India. Geological Survey of India is tasked with over 1,000 exploration projects. Yes. It sets a target to recover these many minerals from waste, electronic and industrial waste. Yes. Okay. Next.